Hello. No. Oh, false start. Hello. Welcome back. It is Tuesday, the 16th of December. I should really say something before I go live. Oh man, it's all right. I can either cut that out or keep that in because funny. Hope you all are doing well. Today we are going through not the NSA. We're going through the TMUA 2016 paper 2. So I know I've been going from 2023 backwards in time, but I'm looking ahead. I'm about to start a bunch of Christmas intensives on the TMUA, which I imagine are going to go forward in time. And so what I'm going to do is start going from the earliest available paper forward just to make sure I stay ahead of the curve. I also am not decided as to whether I'll do 2017 because that's a paper I've been using to do. I think you'll find them far easier than the later ones. Almost certainly. It'll still be good exercise to kind of like, almost more of like a paper one, where paper one is certainly less challenging than paper two in terms of like the pure logic side. So I think there's still something to be said in terms of like exam technique and skills. We'll see. Like I say, the 2016 for me is going to be a complete blind live solve. 2017, I've done a lot with students, sort of chopping it up and explaining the questions. So that might not be the best in terms of showing proper exam technique, but I don't know, TBD on that. I've also got a bunch of paper ones where I still think it's worth me going through the paper ones just to sort of see if there's anything lurking in there, any sort of little traps. I almost wish, because I'd done the 2023 one right off the start because I think I wanted that done in time for the October cycle. And what I really should have done is gone forward in time from then. But by that point, because they were blind solves, I didn't know that was going to happen. Didn't know they were going to be harder in modern times. So there's a non-zero chance I might repeat them, but I don't know. Hey, we'll see. Open to suggestions on that. Now, in the meantime, I've got the practice paper, the 2016, loaded up and ready to go. So I think without too much faff and further ado, let's get into it. All right, I haven't got my little phone stand, but that's quite all right. I will set the timer for 75 minutes, as always. So that is ready to go. And let's begin. All right, so here, in fact, nope, that's all right. Timing won't be an issue, I don't think, as much here, but let me just adjust the screen so I've got more space. Oh, why is that not automatically going? No, I'm going to pause, I'm going to reset. Let me just do a tech thing. Oh, you sat the October one. I say the difficulty is the same as 22, 23. 23 was hard. 23 was just really difficult. Yeah, I really struggled with that. Mind you, it was also the first one I was doing as a live solve, so I was kind of getting used to that as well. But yeah, no, that was legit difficult. Which is why I'm curious to see if there's if it's worth me redoing it to see if I do any better. Or whether it'll just be a pointless waste of time because I've already seen the questions. Let's resume. All right, so this should hopefully be not too bad. So here, integral from 1 to 2 of, that's going to be x to the 4 minus 8 minus 16 over x to the 4, which is 16x to the minus 4, dx, which is going to be 5th x to the 5 minus 8x, raise the power to minus 3, divide by the minus 3, making sure not to make any execution error there. We got the 2 and the 1, so that's going to be 32 over 5 minus 16 plus 16 over 24, which I'll simplify to 2/3, minus a 5th minus 8 plus 16 over 3. Just making sure I didn't do anything stupid there. Square the first, and twice, that should be a plus, actually. So I did do something silly there. So then that should be a minus. So square the first, square the last, and twice the middle 2. This is just my brain warming up into the day. All right, so that should be a minus 2/3. That should be a minus 16 over 3. Okay, right. Something just fell off, so I'm glad I checked that. Now, we have 31 over 5. That turns into a plus to make that minus 8. We have minus 2/3 plus 16 over 3 is plus 14 over 3. Okay. Apologies for my brain just taking a little while to warm up today. Probably can't afford that in the real thing. Right. Okay, let me lock in. So we got 93 over 15 minus 120 over 15 plus 70 over 15. So we got 163. 163 minus 120 is 43. Apologies, let me scroll down so you can see. 63, 43 over 15, which is A. Okay. So that's good. Like, as always, I'm going to be pointing out my internal process as well as I move through, and I can just notice my brain isn't just firing in the usual quick way. So I'll try and, as I move through the paper, build that up because I'm going to need that by the end in terms of time management. We've got our function. We got to differentiate it. That's not going to be too bad because I'm going to first just call that 2x cubed plus 10x. And then that is all going to be times x. Now that would be 3/4, but it's on the bottom, so it's minus 3/4. And when I expand that through using my power laws, 3, which is 12 over 4 minus 3 over 4 is 9 over 4. So that's 2x to the 9 over 4. And that's going to be plus 10. Now these are multiplied. So again, we have x to the 1, and then you add the power. So that just becomes 10x to the quarter. I'm going to differentiate that, and I'm going to get 9 over 2x to the 5 over 4. Just slowing down to make sure I don't make any silly execution errors. And the answer, therefore, is B. Sweet. Okay. Largest angle. Hold on a minute. Let me just... Come on. There we go. No. Okay, let's just zoom out. So what's the smallest value? What's the value of the largest angle x in this range that satisfies this equation? Well, I'm looking at that and immediately thinking, let's just convert the cos squares into sine squares. So we have 8. And by the way, I always like to write, just to speed things up, I'll write my sine as just s, and I'll write my c as just c. So that becomes 4, 1 minus sine squared equals 7, which means that 4 sine squared plus 4 equals 7. Oh, God, this is... I can't believe this is a paper 2 question. So which means that sine is plus or minus root 3 over 2. So in that range, well, I can just never, ever, ever be bothered to learn these. So I promise you, every single time will I draw out this triangle. So sine root 3 over 2, that means that theta x is based on pi over 3. And because it's plus minus, I actually want every region in the cast diagram. So in that, the highest would be 2 pi minus pi over 3, which is 5 pi over 3, which is D, which is the biggest. Okay, I should be watching out for traps more, though, because just because I found the easy questions easy does not mean that there won't be traps later on. And I've fallen for this before, so I just want to lock in on my question reading. 5 sealed urns. These are labeled these. Each contain the same, and that's in bold, and I'm not going to fall for that again. Learned that from last time. Each contain the same non-zero number of balls. The following statements are attached to the urns. Okay, so P says it contains 1 or 4. Urn Q, exactly one of the urns has a true statement attached to it. Okay, so let's think about this. There cannot be 4 balls because then P and Q would both be correct. There cannot be 2 balls because then Q and S would both be correct. There cannot be 1 ball because then S and T would both be correct. There cannot be 5 balls because then none of them would be correct. So the answer should be that there are 3 balls, which means that earn R is correct. And only earn R is correct. Okay, that's my method and I'm sticking to it. And earn R is answer C. Moving on. Okay, a whole number n is prime if it is, well, this is the statement, a whole number n is prime if it is 1 less or 5 less than a multiple of 6. How many counterexamples are there in the range from 0 to 50? So, okay, so the statement is a whole number is prime if it is 1 less or 5 less than a multiple of 6. So what we should do is we should consider those. So let me consider my multiples of 6. So I've got my 0. In fact, let me zoom in just for a bit bigger. So we've got 0, 6, 12, 18, 24, 30, 36, 42, 48. That was embarrassing. I promise. Silly tech. I promise you, I know my times tables. Right. So 42, 48. So what we're saying is this claim is being made about numbers if it is 1 less or 5 less than a multiple of 6. So in other words, 5 less would include 1. 1 less would include 5. 5 less would include 7. 1 less would include 11. 5 less would include 13. So you can see we have these numbers that are straddling these multiples of 6. So carrying on the trend, we're considering 35 and 37, 41 and 43, 47 and 49. So now we just want the ones that are, so what this is saying is if this is true, then it is prime. Let's look at the ones that are not prime. This will be embarrassing. 25 is not prime. 35 is not prime. 49 is not prime. Am I being silly about any of these other ones? I think the others are all prime. Well, 1 is not prime, actually. So let's put that in the mix. Sneaky. Prime, 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 prime. Yep, yep. If I have time, I'll explain as well how to quickly check if something is prime, just in case you need that skill. But I'm going to go with the answer being 4, which is C, but I will make a note to check that just in case I've done something silly. So question 5, make a little note. And we'll move on. Okay, let me zoom out because this is just not going to fit. Okay, this looks like it's actually, let me see. So series of functions defined by the following. So if I have f1, now what I'm always going to do in this case is just try out the first few to see if I can spot a pattern. So that means that f2 of x is going to be x times 10x to the 9, which is 10x to the 10. f3 of x is going to be x times 100 x to the 9, so it becomes 100x to the 10. So in other words, f of n of x is 10 to the n minus 1 times x to the 10. Got it. Find the value of then the sum from 1 to 20 of those n's. Now, apologies for I'm not the most rigorous notator, but this is just for exam techniques, so answers are answers. Yeah, you've got the trick. Check the numbers up to root n. I'll come back to explaining that. Good that you know that, though. Okay, so back to this question. So the sum from 1 to n on that. So what that means is we got x to the 10 and 10x to the 10 and 100x to the 10, etc. So that is going to be x to the 10 into 1 plus 10 plus 100, etc. So that is going to be x to the 10 into, now this is going to be a geometric series with a first term of 1. So it's a into r to the 20 minus 1, and r is 10, apologies, all over r minus 1. So in other words, it should be x to the 10 into 10 to the 20 minus 1 all over 9, which looks like answer C. Okay. Moving on to 7. For real numbers, A, B, C, and D, all greater than 1. So they satisfy the equation that log to base C of D is the square of the log to base A of B. Constructive proof. Oh, this looks interesting. This looks fun. Oh, I'm going to enjoy this. In this case, it follows that this thing is true. Okay, so let's say, let's start here. Let's start from 1. So let's say that x is equal to log A of B and y is equal to log A of C. That means that a to the x equals b and that a to the y is equal to c. Or is that true? No, that's not where I want to start. That's not where I want to start at all. Let me do this again. Let me start off. Okay. So where's my starting point for this proof? So what I'm going to do is say, so I'm going to start here. Backwards is probably easier. Yeah, true that. So no, I can do this. I can do this. I can do this. All right. So what this means is that, let me just follow this through. So c to this thing is equal to d. No, okay, what I'm gonna have to do, let's use some exam technique. Let me actually look at these and see how I would fit this together. Oh no, let me start with the multiple choice. Okay. So all of them start with 1. So I actually do need to start with 1. Sorry, bad exam technique on my part. Okay, that's how I'm gonna do this. So we are gonna start with 1. So 1 says let x equals log a of b and y equals log a of c. We know that's the start point. It tells us that's the start point. So that means a to the x is equal to b and a to the y is equal to c. That definitely follows. Now, all of these next ones have a d equals. Okay, so then looking up here, we know that d equals c. Well, that's log to base a of b is x. So that means log to base c of d equals x squared. So that means c to the x squared equals d, which is number 3. So then looking at here, my next one is either 5 or 7, which means we're going to do something with replacing the c, but c is a to the y. So this is a, there we go. So c is a to the y, and that is all being raised to the power of x squared, which means that d is equal to a to the yx squared, which is 5. So then it's 135, and the answer has to be C at this point. But just following it on, so 135, then 9, which is correct. Then 7, which is splitting out the powers, hence 4, because a to the x is equal to b. Hence that is required. Yep, got it. Okay, that was fun. Exam technique. So 8. A region is defined by these two inequalities, and we have 3 statements to consider. Which of those statements are true for every point in the region? Which of the above statements are true for every point in the region defined by those inequalities? Okay, so let's graph these. Do I have? No. So the first one, we've got y is bigger than minus x plus 6. And in the second one, we have y is less than x plus 4. So we've got a sort of x plus 4 situation. We have an x minus x plus 6 situation. We want y's to be bigger. So this would be y equals 6 minus x. And this would be y equals x plus 4. We want the y's to be above this line and below this line. So that's everything in here. Where do they intersect? That would be a good place to start. So where does minus x plus 6 equal x plus 4? Well, we have that 2 equals 2x, which means x equals 1 and y equals 5. So this point here is the point 1, 5. So in this region, it is not true that all the y's are bigger than 5 because we have these y's that are less than 5 that are in the region. It is true that x is always bigger than 1 in this region because it can't be equal to 1 because these inequalities are strict inequalities. So 1 is correct. And let's consider 3. Now I can see where this is coming from. So they're arguing that this thing is always bigger than 6 and this thing is always bigger than minus 4. So when I multiply them together, am I getting something bigger than minus 24? I don't think that works. I think I can get something less than minus 24 if, for instance, I had so let's consider the case where x plus y equals like 1,000 and x minus y equals, I don't know, minus 2. As would be the case if x equaled like 499 and y equaled 501. If that was the case, then if I multiplied those together, I would get minus 2,000, which is very much less than minus 24. So I think the only one that must be true is 1. So 1 only is B, and I will lock that in as my answer. All right, moving on. Question 9. Triangles A, B, and C have the same area. Which of these conditions taken independently would imply that they are congruent? Time check as well. Whoop. Yeah, I'm doing great. Okay, so if they have the same area, well, let's think about how they could have the same area and not be congruent. Area is a half AB sine C. So, okay. Or maybe let me just draw. It's sort of how to get into it, how to consider it. So let me think about this. Do I go backwards or forwards? Let me. Which of these extra conditions taken independently? Okay, so let's try. And construct. Okay. Okay, so 1 doesn't work, and I can see that because let's say we had this situation versus this situation. If this was BAC and this was YZX, if this was, for instance, I could make that 10, make that 12, make that 10, make that 12. As long as the sine of these angles was the same. So if this is the acute and this is the acute, this is the obtuse. As long as the sine of the angle would be the same, which it very well could be, then the area would be the same even though they're not congruent. So one does not imply congruence. Case 2, if ABC equals XYZ. Okay, so in other words, let me draw that's case 1 I've considered up there. Let me not circle it because it'll look like an answer. So that's case 1 I've considered. Let me consider your case 2. If this length equals this length, and then the angle is the same angle. And the area is the same. So importantly, so if that was AB, so that was 10, say that was A, that was B. Could it be done? I think I can make this work, actually. I think if I swap those around. So for instance, let me see. So I think it's really going to hinge on this idea of the sine rule here. So if I, okay. So if I instead take this and work with this, how could I arrange these triangles to make condition 2 be true? So for instance, here, this third angle could be the one. This third angle could be the one that's the same. So let's say that was B and that was Y. And then I swapped it around, so this became A and this became X. So these could both be, I don't know, 15, obviously not to scale. But that's just to make it work so that I could fit another obtuse angle in, and I could call that 10, I could call that 10. So then that would be true, and that angle would be true. And they would not be congruent, so therefore 2 does not have to be true. And then let me consider 3. 3, I think, is going to be locked in. Because as long as 2 angles are the same, then the third angle is the same. All the angles are the same. So all the side lengths would be the same for the same area. So condition 3 does imply congruence, but the 1 and 2 don't. I think that's okay. And I'm going to lock in answer B. For 1 is not, 2 is not, 3 is requiring congruence. Okay. There was a bit more thought involved, though. And I don't like those ones because you always feel like, oh, have I just missed something? Have I not considered one tiny little subcase which blows the whole thing wide open? But you just got to do your best and trust yourself. Okay, so in 10, in this question, X and Y are non-zero real numbers. Which one of the following is sufficient to conclude that Y is less than X? Let me write out my sufficiency. So it's a statement, and then X is X less than Y. So the statement can be true or false. This inequality can be true or false. Sufficient means the statement gets you there and does not get you anywhere else. So there can be another way at arriving at that inequality. But if I have the statement, it will always lead to the inequality. So if I have the statement, I will always get there. So which of these is that? The way I test that, is it possible to have my statement be true and arrive at something where this inequality is not true? Okay, so let's consider this one by one, which is sufficient. So if x to the minus 1, no, let me start from the top. X to the 4 is less than y to the 4. I don't think that's sufficient because I think that can be true. And y still be bigger than x. Because, for instance, let's in the first case, let's consider x equals minus 1,000 and y equals 1. No, that's not what I meant. Other way around. Let's consider x equals minus 1. No, do I mean that? Hold on a minute. No, let me think about this. Okay, why don't I draw? No. Yes. Let me draw the graphs. That is y equals x to the 4 graph. How can x... And then I'll draw a 1 over x graph. So let me start from the y to the 4 graph. Can x to the 4... Can x to the 4... Can a value to the 4... Yeah. Okay, so in this case, if x was equal to 2 and y was equal to minus 3, then x to the 4 would be less than y to the 4, but y... Oh no, y would not be bigger than... Yeah, exactly, but y would not be bigger than x. So that does work. Okay, so A doesn't work. Similarly, B. Is there a way I can make this work? So can I have this be true and have y be less than x? Yes, clearly. In the case where y equals 1, x equals 2. That works. So I'm looking to break this, so I got to bear in mind, I'm looking for where y is less than x. Okay, so neither A nor B. Cool. Let's go over here and consider the 1 over x case. Can I get... I need y, so I'm looking for... let me write down this condition. I need to hunt for where y is less than x, and these conditions are still true. So is it true that y is the smaller one, but that 1 over x is bigger? Well, let's consider... So here, this one is smaller, and y over x is bigger. So that's the case C, where 1 over y is bigger, but y is the smaller one. So C is definitely... that path exists, so no. D, that I think would be this case here, where if y was equal to minus 1 and x was equal to 1, then D would certainly be true. So the statement would be true, and this would be false. Okay, so it's neither of A, B, C, or D. Right. Now let's check for E and F. Well, I think F is trivially going to exist, because if y was equal to 1 and x was equal to 2, then we could see that 1 to the 3/5 would be less than 2 to the 3/5. So this statement would be true, but y would be less than x. So I think the answer has to be E by process of elimination. Woo, that took some time. But speaking of time, I got 45 minutes. I'm halfway through. I've spent half an hour, so I'm doing okay. But I definitely want to pick it up. I feel like I'm not on my absolute sharpest today. Certainly better than last week, but I still got more to prove on this, I think. So f is a polynomial, and I'm not falling for that again. Polynomial, not a function. The equation f of x equals 0 has exactly 2 real roots. Consider the following 3 statements. The derivative is 0 for exactly 1 value between them. So it's a polynomial. I have to remember that, because I'm not going to fall for that whole... It could be a reciprocal graph issue. Which of the statements must be true? I think statement 1 must be true because if it equals 0 in 2 places, and it is the whole point about polynomials is they are continuous throughout. So to be continuous throughout and not have an asymptote in between, to get from 0 on one side to 0 on the other side without being 0 entirely in between, which would still make more roots, then it has to be 0, it has to move off 0 somehow, and then it has to turn around and come back. So I think statement 1 does have to be true. So statement 1 is correct. So to show that point, if that was there, in any situation, it would go through that. It would have to turn around and come back to make it back to the x-axis. 2, the area between the curve y equals f of x and the x-axis and the lines x equals minus p and x equals p. This would be true if it was perfectly symmetrical about the y-axis, but there is no need for that to be true. So it could do something, for instance, like this. So this would be the case, for instance, if y was equal to 1 minus x into x plus 1 cubed, then it wouldn't be symmetrical and this wouldn't work. So 2 does not have to be true. Statement 3, the graph of that thing intersects the x-axis at those points as well. I think that does have to be true because I know from my transformations, minus f of minus x is a rotation of 180 degrees about the origin, which would flip those points onto each other. Or alternatively, when I do the f of minus x, those points flip onto each other, and when I multiply the whole thing by minus 1, those are 0 points, and so they don't change. So I think 1 and 3 have to be true, and that makes it f. Again, we'll see if I've missed anything. So for 12, the first term of an arithmetic series is a, common difference is d, the sum of the first n is denoted by Sn. If S8, which I'm going to therefore say is a into, this is an arithmetic actually, so I need to know my series sums. So I know the general Sn is n over 2 into 2a plus n minus 1d, which means that S8 is 4 into 2a plus 7d, which is 8a plus 28d, and S6 is 3 into 2a plus 5d, which is 6a plus 15d. So what they are saying is that S8, which is 8a plus 28d, is bigger than 3 lots of this 6a plus 15d, and so, which is 18a plus 45d when I expand it out. What that means is minus 10a is bigger than 17d? Okay. Okay. Okay, so what does that mean? Well, let's think about this and what that would mean. So we know this is true. If these are, let me consider my multiple choice and see which ones allow for this inequality to be true. If a and d are both negative, then that is true. Hang on a minute. No, I'm doing this the wrong way around because I have to start here and see what that means about. So, okay, let's think about how this can be possible. Okay, but it's about the signs. So let's consider a and d. If a is positive, then this is very much a negative number, which has to be bigger than this thing. So this thing has to be negative, which means d must be negative. And if a is negative, that is now a positive number. which means that D could be positive or D could be negative. But just, so if that so D could be positive as long as it still keeps it less than that. So I don't think we can deduce the signs because these all three of these are possible. And so they can both be positive or negative in different instances. So I think the answer must be F. Okay. So 13. So this is still offering some resistance, this paper, even though it's the practice paper. That's good to feel. Okay, so 13. Okay, time check. 37 minutes. I do have to pick up the pace a bit. I think I'm explaining myself too thoroughly in the first run. In this question, these three are positive integers. Oh, okay, this is going to be fine. The following is attempted proof of the false statement. Which line contains the error? So if A does, so the if A does not divide B, and A does not divide B, so they're doing the contrapositive, so they're flipping them around and negating. So if A divides neither of them, then A does not divide that. That is true. Suppose A does not divide B. So suppose this if statement is true, then the remainder when dividing B by A, then there is a remainder dividing by A, and there's a remainder dividing by C. Got it. That's true. That's when I multiply them together. Now, 5. 5 is wrong. 5 is wrong. 5 is wrong. The reason why is because RS could have a different remainder when divided by BC. So for instance, let's consider if R 6 and 7. Let's say that there was a remainder of 6 and a remainder of 7. So R was 6 and S was 7. If I multiply this together, I get 42. So let's say I was dividing something by 8 and had a remainder of 6 and a remainder of 7. When I divide this by 8, the remainder isn't still 42. The remainder would be 2. So I think that's the problem. And I'll explain that more later. But again, I actually want to put together a good run. Now that I've got that solved, I want to make sure I have enough time to go through other things. Because I've still got 5 minutes per question left, and I might need that. So we've got a polynomial. It's a quartic. This is fun. This is fun. This is fun. God, okay. This is fun. This is fun. So let's consider. Sorry, I had to sort of discuss the general shape of it. So let's consider that for a positive and that for a negative M. Negative, so like as a negative quartic. So in this case, I can have 1 solution, 2 solution, 3 solution, 4 solution, 3 solution, 2 solution as I move up. And here I would have 2, then 3, then 4, then 3, then 2, then 1 as I move up. Now, the reason I say that is because we're looking for equaling different y values. So these lines could be the increasing y values. So as I increase from 1 to 2 to 3 to 4. So in other words, as I increase, so P to Q to R to S, I can have 1, 2, 4, 3. That is legit. I can have 1, 3, I can't have 1, 3, 2, 4 on this one. Can I have it here? No. So I think the answer is B, but let me just prove that on the others. So I can have 1, 4, 3, 2. That'll be fine as I move up this graph. I can have 2, 4, 3, 1. That's fine. I can have 4, 3, 2, 1. That's fine. The answer is B. Not possible. Okay. 15. Consider this quadratic. This quadratic has 2 real roots whose difference is greater than 2 and less than 4. Okay, so this is the difference between 2 roots. Let me get the general roots. So the roots will be 2p plus or minus root of b squared minus 4ac all over 2a, which would be p plus or minus the root of p squared minus q in this instance. So that means the difference between the roots is twice this square root. And that difference lies between 2 and 4. Which means that the square root lies between 1 and 2. Which means that p squared minus q lies between 1 and 4. Which means that if I add q to both sides and I subtract 1 from both sides, if I subtract 4 from both sides, I get c. Oh no. But if I subtract 1 from both sides, I get d. But it's the less than and equal to that's the problem here then. So c can't be right because of its sign. If I subtract 3 from both sides, I do not get e. So it's not c. I'm going to get rid of that. I think the answer is D now. I think P doesn't work because I think if you square root, it's going to cause him a whole bunch of nonsense. And then, yeah, this doesn't work because it should be Q plus 1 on the other side. Okay, so I'm going to lock that in. Why is that a perfect circle? I think that was D. Yes. Okay, moving on. Right, this looks vaguely vectory. So we got 16. We have a cool little diagram. We have a trapezium. That's parallel. That's going to be important. Oh, God. All right, let me just draw it out because I'm going to want to doodle over it. I would doodle over it here on the screen, but you're not going to be able to, so I won't either. And I'm not going to use straight lines because you'll just have loose notebooks anyway. So here they're all parallel. What is the length of UT? Okay. What angles are the same? That equals that. I'm looking for a similar triangle sort of situation. Because it kind of looks like it wants to move linearly through. So there's going to be some sort of scale factor going from 3 up here. And as you move down, it's going to move smoothly to 12. So the question then becomes, when do these intersect? No. Okay. Oh, hang on a minute. I'm looking for... No, let me not consider those angles. let me consider instead. Okay, so okay, if that's A, then that's A. If that's B, then that's B. But then I have that Z here as well, which means this is also A. And I have that Z there, which means this is also B. So I know that these are similar triangles. The one at the top and the bottom. So that would be C, and that would be C. Which means that CAB, so that would be B, and that would be A. I wouldn't expect these to be similar. So, all right, I've loosened the gem jar. I'm going to use a tactical skip here. I think I'm going to be okay on that, but I'm just going to need some time for that to percolate. Like I'm not going to get that instantly. And I want to be tactical with my time because I've got 27 minutes left for 5 questions. Yeah. So consider these simultaneous equations. Which of the following statements must be true? Well, let's plot this out. 3 sine x plus 2, it will start at 2. It has an amplitude of 3, so it'll go up to 5, down to -1. Let's do something like that. Y equals x plus c. Well, the gradient of that is 1. And when will that be parallel to, because we're talking about exactly one solution. For there to be one solution, it has to be tangent. So if I differentiate this one, I'm going to get, oh no, I'd get 3 cos x, which equals 1. Okay, so, oh, no. It's just looking in different ranges. Okay. So let me now consider what happens when I have a straight line and kind of move it through. So for instance, I could do, well, let me first say what I got going on. So we're talking about, so that there is pi, and that there is minus pi. For some value of C, there's exactly one solution in this range. Well, how is that possible? There's 2 ways in which that's possible. It's either glancing blow there. Now, this gradient, these max gradients are 3. So there's at least one solution here and one solution there. So let me, 2 might be easier. Is there a place where there's exactly one there and none there? What am I missing? No, again, I'm going to come back to this just to see if there's anything that comes apart a bit easier. But I've got into that. So 18, consider this statement about a function. Okay, so anything squared is positive. So if I'm going to be more restrictive on that, actually, if squared is that for all of that, it means that the absolute value lies. So that is possible if this statement is true. and that is for minus 1, x between -1 and 1, then so if this is true, then well, for it to be a counterexample, first let's see if this is true for these different functions. So it's not true for A, because when x is equal to 1, it's outside of that. It's not true for B, because when x is equal to -1, it falls outside of that, f of x falls outside of this region. So the claim is not made about A and B in the first place. I think we're fine. Well, let's check. I don't think we're talking about C either, because when x equals 1, f of x equals 2. And for the same reason, I don't think we're talking about E, because when x equals 1, f of x equals 2. So we're only really talking about D or F. So that really simplifies things. Now, let's consider the integral from -1 to 1 of x minus x cubed dx. Well, that's the integral from -1 to 1 of x dx minus the integral from -1 to 1 of x cubed dx. Now, importantly, these are both odd functions, which means these will actually both be 0. Because there will be a negative area on the negative x and a positive area on the positive x, and they will cancel out to give 0. So actually, these will both 0 out. So the right-hand side would be 0, but the left-hand side, anything squared is positive, so that would be a positive area. So I think D is a counterexample. And on F, I think we're fine, because when you square these things, you'll get something smaller, because these will all be fractions in between -1 and 1. I think, and the reason I think the why it has to be equal is because if it's actually equal to 1 or -1. But I'm going to lock that in. I think that's okay. 19. How am I doing on time? 20 minutes. So you see how much I check the time just to make sure I'm keeping good pace, especially towards the end. Okay, let's just sort of get into this. So identical unit cubes are used to construct a 3D object by gluing them together face to face. Sketches of this object are made by looking at it from the right-hand side, from the front, and from above. These sketches are called the side, the front, and the plan view, respectively. How many cubes were used to construct the object? Well, this is the side view. This is me looking at it from the side. So why don't I look at it from the front? Because that's what I would be doing in real life. And this is me looking down on it from above. So I know this goes a little bit deeper. Maybe I'll look at it, do the plan view. Yeah, I'll do that. So that this would be this here would be the front view. So why don't I draw this out? Where this would then be the front view, this would be the side view. So from the front view, I can see this would have 2 cubes on it. This would have 1 cube on it. I know from the side view, this would have 3 cubes. This would have 1 cube. But now let me consider this corner piece. The plan view is set anyway. The front view is now actually complete, because I would see 2, 1, 3, regardless of what this is, as long as it's something. So that could be a 1 or a 2 or a 3, and the front view would be okay. From the side view, that can't be a 3. Because that would then push that too big. But from the side view, 1, 3 are satisfied. If that was a 1 or a 2, it would see 2 there. So this is now complete. which means it's actually ambiguous. And we have 4 and 3 makes 7. So it's either 8 or 9. Cubes are used to make it, which is F. Okay, and then 20. Each interior angle. Well, I actually like going via the exterior angle. So let's do that first. Exterior equals 360 over n, which means the interior is 180 minus that. So each interior angle of a regular polygon of n sides is, so what we're saying is that the interior here is 3/4 of the interior angle with side m. So 720. Well, no, let's divide. First of all, let's divide both sides by 180, just to make my life easy. So 1 minus 2 over n is 3/4, 1 minus 2 over m. So 4 minus 8 over n is 3 minus 6 over m. Let's get one in terms of the other. Now, let me think about this. Which one's going to be more restrictive? So for this to be true, the interior angles on n are smaller. So that's, for instance, the case of the regular triangle as compared to something else. So n has fewer sides. And so that's the one that's going to be restricted because you can't get less than 3. We know that n has to be bigger than 3. So I think that's the most restricted one because that's underneath m. So why don't I find n in terms of m? So I'm going to make n the subject of the formula by saying 1 plus 6 over m equals 8 over n. So n equals 8 over 1 plus 6 over m. And I'll multiply top and bottom there and say that that thing has to be bigger than 2. That doesn't seem like it's going to get me anything. So 6m has to be bigger than 12. So m has to be bigger than 2, but we knew that. Okay, let me try the other way then. Let me get m in terms of n. So I'll kind of keep that in line of sight and rearrange it differently. So 6 over m equals 1 plus 8 over n. Is this gonna... Which means that m is 6 over 1 plus 8 over n. So it's 6n over n plus 8. Okay, so this can definitely be done. I still think n is the most restricted. Maybe m is restricted. Yeah, you want integers. That's a valid point. That's true. Like I know. The annoying thing is I know I solved this months ago. I just can't remember the solution path. Let me think how I did this. Oh, hang on a minute. Oh, hang on a minute. Does this cause issues? Let me try some N's and M's and see if I can spot something, because I think N. So that would be 18 over 9, which is 2, which doesn't work. Is M the smaller one? No, it would be 18 over 11, which doesn't work. 24 over 12 is 2. Oh, it is. Is M smaller? Maybe I got that wrong. Hold on a minute. No, I thought N had to be smaller. Have I done something desperately wrong? Hold on. Right, so 12 minutes left. I've got 3 questions left to do. So I'm just sort of nebulously going around this. Hey, thanks for all you do. When do you think you could post tricks for ESAT questions? I'm going to do that on my next... I'm going to do that on a live stream after I've done my interview prep. So that would probably be from next week. Because I think the ESAT stuff, the papers, I've got lots of good solves down already for the ESAT. So I'll kind of do that more as like my evening streams now that the interviews are done. Thanks to be there. Great. Look an eye out. I'll put posts on the community page, and I'll make sure to populate the stream in advance with the title so you know what I'll be discussing. So don't worry about that. Now for this, 12 minutes. Where am I going to... Okay, I've got to be tactical about this. Why don't I just keep going? Did I solve this correctly? Three-quarters of each interior angle of a second. Divide by 180. Multiply it by 2, multiply by 3. I did get this wrong. This should have been 6 over n. This should have been minus 1. Okay, let me do this. I think I've got this. See, a little bit of fresh eyes. All that's required. That just felt intuitively off because I knew that n should have been less. I was right. Okay, so move that over equals 8 over n minus 1, which is 8 minus n over n, which means that 6n over 8 minus n equals m. Great. Now we are very much limited here because we also know that m has to be positive. Great. Which means n has to be less than 8. Love that. So n is between 3 and 8. So let's try all the possibilities. 3, 4, 5, 6, well, 7. It can't be 8 because then m blows up. Then m would be 18 over 5, which doesn't work. It would be 24 over 4, which is 6 and does work. It would be 30 over 3, which does work. It would be 36 over 2, which works. And it would be 42 over 1, which works. 1, 2, 3, 4, E. Great. 9 minutes left. I think, which ones did I skip? I skipped 16 and 17. 10 minutes a pop. Let's go. Yeah, hated that one. No, this one, 16. I know I can do 16. Oh, okay, so the fact that that's 3 and that's 4, those are the equivalent sides. I know that the scale factor here is it's a 1 to 4 thing, which means that in these heights, it will also be a 1 to 4 thing. So if that's y, that's 4y. In other words, I am 1/5 of the total way through. Nailing it. So in other words, I am 1/5 of the way. So it's the difference. So let me do a sort of similar to stats, linear interpolation. So I know I'm 1/5 of the way through from 3 to 12. So what would that be? Well, the difference is 9. 1/5 of that would be 9/5, and let's add that to the 3 to get the full length of UT, which is 1 point, because I think I remember this. Yeah, 1.8 plus 3 is 4.8, which is C. Lock that in. Nailed it. Love a good fresh eyes. Now let's think about 17. Okay. How am I going to get around this? Because I'm just having an issue with gradients and whether I can be, because this is a loose sketch. I'm like, oh, but what if it like actually goes through, or what if it touches once? But I'm just having a gradients problem, and whether something would be a tangent. So here, is there a C for which I intersect once? Because for instance, I kind of want to go, oh, well, if I just draw one that goes like this, it'll work. But I don't know, is that possible? Is that gradient 1? Or actually, is the fact that that's 1 that's going to like limit it in some way? Because another possibility would be something like this. But you can see these are wildly different gradients now for making 2 work. And I don't know with a rough sketch how am I going to work that through. Why don't I say for 17, let's consider, well, I know if C is equal to 2, that it will be 2 and 2. 2 solutions in each. I know this with certainty. And I also know if that is, so if C was pi, then it would cross through there. And then that would be 3 higher. So this would go to pi plus 3, which is bigger than 5. So no, so if it's tangent there, it will absolutely cross once there. So 1 is correct, but there's definitely a 1. Okay, how am I doing on time? 5 minutes, great. Okay, so 1 is definitely true then. 1 is definitely true then, because if that is 5, and I track back 3 pi over 2, which is roughly 9 over 2, which is certainly less than 10. No, I can do this. So let's try and find a case in which there's no solution, which is what I've done here. For it to intersect here and not to intersect here from above, that would be missing the point sort of minus pi 0. And from that point, if I'm going up with a gradient of 1, I'd go pi. That would be pi up. And then there I've added, oh no, even better than that. That would be pi 3 on the line. It would be pi over 2 plus pi, so 3 pi over 2. Oh no, that would intersect. That would intersect. That would intersect. So 3 pi over 2 is less than 5. So I think 2 is correct. So it's certainly, if it has a glancing blow, it will miss that. Ah, damn, I'm just not seeing this one. 3 minutes left. Okay, so there's exactly one solution where it goes between 0 and pi, and there are no solutions with x bigger than pi. Well, that's clearly true. So 3 works. Okay, so I'm picking between D, F, G, H. Well, I know that 1 is also true, I think. So it's only whether 2 is true as well. There's exactly one solution between 0 and pi, and there are no solutions in here. Is that possible? I'm going to say it is possible just because of luck. I just hope I get lucky. Again, I'll be curious to see the work solution on that. I know I'm missing. I'm just reaching around the edges of it, and it's frustrating that I'm not getting there, but it was a sensible guess, and it's giving me a good chance. With a minute and a half, I'm just going to stop the clock there, lock those in, and kind of see how that went. So, not a great run. It's probably not a full marks run. I don't know. We'll kind of see. I'm going to mark it up first, and then we'll go through anything. Like I say, I wasn't feeling it 100%. I didn't feel, because like last time I was absolutely just devastatingly tired, and I feel like I'm able to like show up and communicate and explain what I'm thinking, but I think in terms of like my sharpest thinking, it's not there for some reason, which is quite interesting. So I have to find a way to, because in terms of exam technique, kind of making sure you show up at your best on the day is important, and the fact that I couldn't, not my best, but it's fine. Let's see how not my best did today. Question 1, the answer is A. 2 is B, correct. 3 is D, correct. 4 is C, correct. 5 is C, correct. 6 is C, correct. 7 is C, correct. 8 is B, good. 9 is D. Okay. We got 9 wrong. Let's discuss that. 10 is E. 11 is D again. Ooh, I am off today. So we got 11. 12 is F. 13 is E. 14 is B. That was long. 15 is D. 16 is C. 17 is H. Yay, got that one right. That was lucky. 18 is D. 19 is F. 20, I felt good about that, is E. So actually, weirdly, the ones that I found hard, I got right. And it was the ones that I thought I would have done fine on that I made my mistakes. So let's go back to 9 and 11 and find out what went wrong there. So I got 18 out of 20. 18 out of 20 again. So we're still up at my top score. I really want to get a full marks run, like I did in the ESAT. 9. Oh, I saw 2 had to be congruent. Okay, I remember this. So let me go back to 9. This was about congruent triangles. So here I argued that 2 didn't have to imply congruence. Because I said in the case that these 2 lengths were the same and these 2 angles were the same. Oh no, of course, that would force these 2 sides to be the same. Because half AB sine C on this angle. And then it would be SAS congruent. That was just silly on my part. I apologize for that. I should have got that. That was an execution error. That was well within my capabilities. Okay. So the problem here is because the angles, the areas are the same. These lengths are the same, these angles are the same. So plugging those in, B is now fixed. So this other side length is the same. And then it's SAS congruent. So 2 was correct. And it was only 1 that wasn't correct because of the ambiguity in sine C. Okay, good to know. Right, yeah, and you're right. Actually, I'll have a bit more time for comments. So we got a comment in. You're applying for CS Cambridge. That's computer science. 7 on the TMUA. Damn. Well done. One of the interviews wasn't good, didn't perform well, or finish all the questions. Hang on a minute, though. What that means is that you showed them where your limit was, which is exactly what you want to do. You don't know whether it was a hard interview or not. For the second, I finished all the questions with very little help and did really well. Yes, you do have a chance. Because it could just be that the first interview was just a nasty interview and that everyone struggled really hard. Like, I have a bunch of people who, weirdly enough, every piece of feedback I've got about Cambridge, the interviews so far, has been about engineering, specifically at Trinity College. Like, I've heard so much about that interview in particular. Like, a lot of people found it very challenging, and so no one thinks they did well. So you don't know how you compare with everyone else, so you do have a chance. You can just walk out with no regrets. Like, you did your best, you showed them your ability, especially in the second interview. So I would just walk out and go, do you know what? The process is going to be the process on this one. And even if it doesn't work out specifically, like, the fact that you did so well in the second interview means that you're also more likely to be pooled if you don't get an offer. So they're more likely to say, oh, this is an actually strong candidate, you should consider them. And remember, it's just based on like how everyone else shows up on the day, which is completely outside your control. So you did your best. I would just sort of take that. But honestly, a score of 7 on the TMUA and a good solid second interview, yeah, I'd say you have a chance. It's not guaranteed, but you have a chance. Right, what did I get wrong in 11? Let me just make sure we correct these first. So I said 1 would have to be correct. 2 does not have to be correct. I said 3. No, this is conceptual. This is going to stump me. What did I do wrong in 11? Ah, that's so frustrating. I didn't read precisely enough. Exactly 1. No, of course it could have multiple. That is so annoying. So I knew 3 was correct. I missed. Ah, damn it. I could have got 19 on that. Oh, it burns. Ah. No. But it's that kind of competitive attitude, which is what pushes you to get better. But like, god damn, that's annoying. Yeah. And you see, that's the difference, right? When it's an execution error, you're like, oh man, that's annoying. But when it's an exam technique error, when it was totally within your capability and you just didn't read the one word you needed, oh, that burns. Okay. Oh, okay. Calming down. We're all good. Right. Now I'm going to go back one by one. I'm going to see if there's anything that needs further explaining or if there were better solution paths in the solutions. So that was my sort of run. That was what I did right and wrong. But now let's make sure you actually come out of this with all the correct answers and solutions. as well. This was straightforward. You just do it at the end. This was straightforward. You just do it. The end. 3 was straightforward, and you just do it. The end. I don't think there's too much that needs explaining in any of those. 4 was just a nice, rigorous logical process. I think that's okay. I'm curious to see if they had a different method that you might prefer. So work through the possibilities. And so instead what they did is they went one by one. I actually don't prefer their method. I prefer my method, where instead you consider how many balls there can be and what that would mean for them. Okay. But what they did, for instance, is they said if P was correct, the correct one, then all the others have to be false. So it can't be the 1 because then T would be correct, but it can't be the 4 because then Q would be correct. And they kind of go one by one that way. I think I found a better path there, so I'm pleased with that. 5. I liked my method there. And again, okay, this is where I wanted to do a bit of explaining. So if you want to quickly test whether a number is prime, if you're having any sort of doubts, because I know when they get a little bit higher, I can get like bad with things like 91, which I think is 17 times. Well, when you get up into there, like the sort of 17 times 7s, or the 17 times 3, it's something like that. Let's check if 91 is prime. This is a great example, right? Okay, so the rule is you have to check all the prime numbers up to root n. So root n, I know I've got, that's somewhere between 9 and 10. So I'm going to check all the prime numbers up to then. So is it divisible by 2, 3, 5, or 7? Because then the next prime pushes me over. It's not divisible by 2. It's not divisible by 3, not by 5. Is it divisible by 7? Yes, it's 13 times 7. So actually, this is not prime. And that is the quick way of checking. So if you want to check all the prime all the prime numbers up to the square root of n. And that's your quick check. So here I could have checked up to the square root of, so it's only really going to be 2, 3, or 5 up to this point that I need to check for. Because 49 is 7 squared. And 2 is really easy, 5 is really easy, so it's just if they're divisible by 3. It's the only real check, which is quite convenient. Okay, moving on. This was fairly self-explanatory. Once you just sort of write out a few of them and set up the geometric series well. 7, I liked the way I did that. So I wasn't really on form. I think it's because I haven't eaten yet today, you know. I think if I'd eaten, I could have gotten 19 out of 20. Maybe even 20 out of 20. But here, I noticed that all of them start with 1, so I had to start there. And from there, what did I do? From there, I spotted everything was d equals. And that was from here. So I said here that this thing was equal to x squared. And so c to the x squared is equal to d, and then it all fell out from there. Checking their path to see if they had a different idea. So here certainly begins with that. So that is that. Great. That is 3. And then, yeah, they just did the exam technique. So you're either choosing between 5 or 7. And they kind of went, okay, so they had my path. Great. And it goes to show, like, sometimes you want to just do the question on its own right, but sometimes it is best to use the multiple choice to your advantage. Question 8, I got right. And I really like the way I explained why 3 didn't have to be true. I think 1 and 2 were okay. 3 is the interesting one. Let's see if they had a better way of explaining that. So yeah, just trying to find counterexamples. Yeah, I think I like using extreme counterexamples, so there's no sort of what if about it. Ooh, another common question. I have a P2 question from October 25. What is your paper 2 question from October 25? Oh, as in the one that just happened. Oh, you bring that. Oh, absolutely. Because I'm not sure as well. Hold on, let's have this conversation. Because I'm not sure that with the new way they're doing them, that they introduced last year, I'm not sure we're going to get past papers released like ever again because they're doing them on different days. So they don't have just one paper that everyone sits. They kind of pull from a question bank and assemble the different papers for the different sessions out of them. So people didn't sit the same paper. So there isn't one paper that they can release for what happened. So I'm thinking these might be like all the papers we get to practice. So if you have specific questions that you sat in an October cycle, let me know because that's just really interesting. So TMUA question paper 2A. Okay, so let me try and work this through. So I'll go back to sharing just so that I have something to work on. Apologies if you're looking specifically for this paper. I'm going to timestamp things so you can skip ahead if you want to. Let me kind of lay out this question that we're getting in the comments. So here we've got a function satisfies f of x plus f of x plus 1 equals 0 for all x. Which of the following must be true? Is it A, that the integral of f of x, I'm guessing this means between 1 and 6 is 0. B, that the integral of f of x between 1 and 4 is 0. Hold on. B integral. Oh no, equals doesn't equal 0. Equals the integral between 3 and 8 of f of x. The integral of f of x between 1 and 3 is equal to the integral of f of x between 3 and 8. D, the integral of f of x between 2 and 5 is equal to the integral of f of x between -1 and 4. Yeah. So let me just check I got A right. Yeah. So how would I approach this? Well, what this means is that f of x plus 1 equals minus f of x. So I think this has to do with like assembling the integrals. So here, integral from 1 to 6. Integral 1 to 2, integral 2 to 3, integral 3 to 4, integral 4 to 5, integral 5 to 6. Now remember, an integral is the sum of all of the elements of f of x times a small dx. And what I'm thinking here is every point here. So when x equals 1, that is the negative. So f of 2 is the negative. So for every point here, to get to the next integral, I'm adding 1 to the x, which means this will be the negative x value. So these will perfectly cancel out. These will perfectly cancel out because every y value here will be the negative on the sort of counterpoint. But I don't think it equals 0 necessarily. Similarly here, well, what I think this means is that on any integral of 2, I think it cancels out. So in other words, I think this one here, oh my god, that's so cool if that's true. Right, let me test my theory there. So that would reduce to the integral from 3 to 4 of f of x. And then I can cancel that down to 2 to 2. Yeah, I think that works. I think that works. But let me check that I'm wrong. So this would be 0 on the left-hand side is what I'm arguing. And then that would be the integral from 3 to 4. So that's why that doesn't work. And then this one, would be the integral from 1 to 4. But no, because but then that would be the integral from 3 to 4. But this would be the integral from 2 to 3. But no, these would be the negative of each other. The answer is B. That's a wild question. Oh, that's made my day, that. I don't know if you followed my reasoning there at all, but the answer is B. And that is a wild solution path. Oh, that is just a scrumptious question. Now, look at how I did that, right? I assembled it. I had no idea what to do there. I assembled it, and I realized the relationship between consecutive ones. So all of these are going to cancel out. And that means on any integral interval of 2, that will sum to 0, which actually means look how I can simplify. I can knock off 2 on the top or the bottom and keep the same value of the integral, which is why I was able to transform the left and the right-hand side of that, raising 2 from the bottom to make it 4, 3, and knocking off 2 each time from the top to make it 4, 3. So these collapse onto the same thing. And then that collapses down to 0, but that's so cool. That's so cool. Yeah, I'm not sure how drawing a representative graph could have worked, but like that's bananas. That was so. Thank you very much for bringing that question. That was a fun question. You see, there's a reason why I do this job. God, that's satisfying. Okay. Yeah, that was wild. Thank you for that. Now let's get back to the boring. 9 we've talked about. 10. I think I liked how I did that. I just came up with counterexamples in every single case. 10. It's a shame they won't release any papers. I agree! Well, I don't know for certain they're not going to release any papers, but I just don't see how they can release papers unless they release the entire question bank. Because it's like, it's really not that many past papers, especially if you're doing something like an ESAT, where like you only have one paper, and it's just bad. At least with the TMUA, you get 2 papers per year, but there's just not that many years available. And I quite agree that moving to the okay, yes, it's bad. Could be worse. You could be doing the PAT test. The PAT test, okay, I'm rant time. The PAT test, though. Like, why have you completely changed the entire format of the paper to go from a long form written paper to a multiple choice online only paper, like online multiple choice only paper? And then you release like no past papers for it. And you will never release any past papers for it. It's ridiculous. How are you supposed to prepare? It makes no sense. And you're trying to prepare people by like getting them to do the multiple choice from the past papers. And then they walk into the real thing. And everyone has said it was not like that. And they haven't released sufficient material for you to actually prepare. It's stupid. That makes me angry. But yeah, it just means So yes, it's annoying, but at least you're not doing the PAT test. They have ruined the PAT test. So if anyone from the PAT test is listening, be better. Just be better than you are. Anyway. So here, yeah, they're just coming up with counterexamples. I liked to do that from graphs. It helped me see it better. But yes, it's all about counterexamples, this question. So the answer is E, because all the other ones you can come up with quick counterexamples. 11, we talked about, I just can't read, but it's fine. 12, I liked how I did that, and I think that's probably how they did it. Why are you making it ugly? Oh no, they got to... Did I make a sign? Did I? What did I do? Oh no, they're wrong. Oh, they're wrong. Oh, I like that. I like when you beat the mark scheme. I can confirm that subtracting 18A from 8A will give you minus 10A, not minus 8A. Nailing it. But yeah, it's basically that. And yes, you consider then the cases of different positive and negative. Okay, so for 13, yeah. If you ever got stuck on this, by the way, you could kind of like... So I was able to do that in the general, but if you wanted to, you could come up with a case study. So you could come up with, for instance, so like if 8 divides 24, 8 divides 4, or 8 divides 6. So in the case where A equals 8, B equals 4, and C equals 6, we can actually run this thing. Well, yeah. So in this case, it would be 0 plus 4. Maybe it's not the best example, but the point here is that the R and the S. So why don't I use the example I gave before? I think I gave when you were dividing by 8 and you got reminders of 7 and 6. Or rather, it might be even better to say... So 8 doesn't divide 12. Nor does it divide 10. Why don't we try that? But it does divide 120. So when A equals 8, B equals 12, and C equals 10, let's sort of run this through and see how this would have worked. So it does work up to here. The remainder is R. So it means that here, 12 equals 1 times, sorry, equals, let me just be very precise about this so you can track it. A was equal to 8 equals 8 times 1 plus a remainder of 4. And C, so 10 is equal to 8 times 1 plus a remainder of 2. But then they're arguing that BC, which is 120, is equal to 8 into 8 times 1 times 1 plus S times 1. So plus 4 plus 2. But then plus, would you look at that, 8? And they're saying the remainder when dividing 120 by 8 is 8, but that's not true. Because in this case, A does divide into RS as well. So 5 is the reason why it's wrong. And it's because you could sort of, RS could itself be divisible by A or have a different remainder when dividing by A itself. So 5 is very much the problem there. I'm curious to see their way of explaining that. Yeah, they just said this is clearly not correct. What happens if it's bigger than A? Exactly. And then they used an example to prove that it's, yeah, cool. So 14, I really like how I did 14, but so as you're kind of moving up the graphs, can you get these various combinations? And based on theirs, I don't like theirs not one little bit. So let's so going through mine, you can get one as you move up the graph, you can get a 1, then a 2, then a 4, then a 3. And then for the others, you can get a 1, then a 4, then a 3, then a 2. And I can just sort of scale the graph as required to make it happen at exact integrals at like intervals of 1 on the y-axis. But like that's kind of how to do this. Then you can get a 2, then a 4, then a 3, then a 1 as you move up, and a 4, then a 3, then a 2, then a 1 as you move up. In the cases where A is negative, it's B that's impossible in either graph, so that's why it was B. 15 didn't feel great. In that it didn't feel like satisfying, so I'm curious if they did it differently. They got the difference between the roots is 2 times that thingy. Good. So that is true. So that is true. I didn't consider the fact that it has to be the discriminant has to be positive, but it didn't really affect the work in this instance. Oh, the first condition is implied by the second condition, so it happens to not be relevant. Okay, but it could have been relevant, so I have to be careful. And then they just rearrange it, which is D. And then they went. I think that's sufficient. And then they go through why the others fail. I liked how I did 16 in the end. This idea of like, once I found that these were similar triangles and the scale factor was 1 to 4, means these heights were 1 to 4, so it was a fifth of the way through. I'm curious if they... Yes. What is S? Well, they kind of argue it. How did they argue it? I think they did a bunch of similar triangles, but I'm very scientific, and so that's just how my brain works, kind of like a linear interpolation method. So you have my method now in case. I mean, Grant, let's be real. You guys are literate. You can read the you can read the work solutions if you prefer the work solutions. But I came up with a different path here, which worked. And I like that. 17. I did not like this question at all. I got kind of lucky there. So this I actually do want to make sure I go through because I just wasn't convinced. But this seems only possible because they've accurately graphed it on a computer. Why could Jake just take C to be less than 2? But how do you know? That doesn't feel sufficient to me. Because if you take a C as less than true, a C less than 2, okay, I can see how you can do that, but how do you know it doesn't? Okay, fine. I suppose with at least one, so yes, okay, fine, that works. Having a C less than 2, so 1 works. But 2. Okay, so they just went under it to make sure it intersected. Oh, it was easier than I thought there. And there is at least one solution. So if I'd gone under... Oh, and I didn't really... Sorry, I got rid of my x-axis here. That was the problem. So going there, it will intersect there, and I can make it miss. Or if I go there, I can make it hit. So what did they say? C to be negative for this case. So if it intersects at exactly that point, it'll be exactly one solution, and then it misses down below. Okay, that was a clever path. So in other words, what they're saying is, and I felt like I was reaching around the edges of it, but my brain wasn't on top form. Again, I'm going to say that's down to lack of food today. Now, so what they're saying there is there's one solution there, and you get multiple solutions there. And then here, if C is negative, so if they're aiming for it to go like, then you can do one like that. and you'd be completely fine on 2. And 3 was kind of just obviously fine, I think. So yeah, not a huge fan of that question, but I was a much bigger fan of this question. Because first of all, with counterexamples, you have to make sure the claim is actually relevant to the statement being considered. So for these guys, the claim was only this first if case clause was only satisfied by D and F, which I think is what they will have said. Not relevant, not relevant, not relevant, not relevant. So you only need to consider D and F. And how did I do for D? Yeah, because this is an odd function, integral between -1 and 1 will just be 0. So that would be 0, but this can never be less than or equal to 0. So D works. Since they're both odd, the area are equal, but the first is above. Yeah. So great. For the sake of completeness, they actually do the left-hand side, but I'm not going to bother. Here, 19, I liked my method, looking at it from the top and then considering the front and the side and what that means and how to satisfy it. So almost all of these are completely constrained, except for this one in the corner, which could be a 1 or a 2. And then it would keep these looking the same. And then I liked the way I did 20 once I did it correctly. So trying to find the expressions for n and m, because making n the subject didn't get me anything useful. It just got me m is bigger than 2. But in the other instance, I managed to get this expression, and knowing that m had to be positive, that really constrained the values of n I was allowed to have. I'm curious to see what they did. Oh, they argued differently for why n had to be bigger than 8. I prefer my method, though. So this would be less than 1. And so, yeah, this cannot give a solution because that would be positive. I prefer, my way makes much more clear that why that becomes an issue when n is bigger than 8, in my opinion, but hey. But then from that point, they just consider the different possible cases, and then you get E. Okay, so that is the practice paper with all the solutions. I got 18 out of 20 on that. Maybe if I'm not going to have a full breakfast, I should at least have something. Make sure I've eaten. Just in my brain, because I think that's it. I got enough sleep. I mean, let's talk about it. So last time was awful. I slept terribly. I clicked the wrong button on the microphone, so the microphone cut out, and then I had to restart the stream. It was just a whole fiasco. So that was why my performance suffered there. Now today, sleep, fine, energy, good to go. Clearly, my brain is not on top form when I haven't eaten yet, which is actually, that won't be so much an issue in Christmas. We're about to hit Christmas. My schedule is going to be upended. So I will start my live solves later in the afternoon. So the food issue shouldn't be a problem. But all these sorts of things are things you actually really have to consider when going in for any paper or any sort of any situation where your performance really matters. Have you slept enough? Have you eaten enough? Like these really annoying biological things or like emotional things, the human side of things that you need to make sure are taken care of so you can kind of just tuck them away and they're not going to cause an issue or a distraction so you can just deliver at your optimal level. All of these things that are actually really important as a part of your process, and all things I consider in my tutoring practice. Like, how are you doing? Like, is there anything you need to adjust? And it's everything that you should be thinking of as well at any point where you really need to show up. So in fact, even like caffeine. So I had a guy when I was at uni. I remember whenever we went into exam season, he would purposely wean himself off of caffeine. I was like, why are you doing that? And he went, well, if something ever happened in the morning, which meant like, let's say I slept through an alarm, woke up a little bit late. had to rush to the exam hall straight away for my morning exam, didn't have time to pick up my coffee, I would crash and I wouldn't be able to perform. So as like an insurance policy against that, he weaned himself off all of caffeine to make sure he could perform without the caffeine if it ever came to that. So all of these things are things that you can start to consider as you consider operating at your absolute highest level. So for me, sleep good. Clearly, I need to eat. I need my blood sugar high enough that I can like focus. I think apart from that, let me think about the actual subject material. I think that was largely fine. I think we've been finding that these earlier papers are much easier. As you move through, they get a lot more logic based. Lots of sort of like if and only if, lots of counter examples, lots of negation logic. That seems to be something they've increased in recent years. So that's something I'm going to really point out when I see that in papers. And I may even redo the 2023, see how I feel about that. If I recognize it too much, I may leave it. But if I think it's useful, I might do it just to sort of make sure that my logic is like at top level. I'm also going to make sure to do some paper ones, like I said, to make sure that there's nothing lurking in there. And I think what I'm going to do is I'm going to focus mostly on the TMUA as we move through into January, because that's where most of my students lie. A lot of my ESAT guys were in October. And I've done 2022 is a good challenge. I think I've done 2022, not the paper one though. So it's good to know if the paper one there is bad. I could do that next. So ESAT, I think I'm going to leave, except I'm going to do my like evening. So I'm not going to do any live solves on the ESAT, but I will break down the ESAT, kind of explain what I see in them, do it more like a sort of seminar session, like I've been doing with my evening streams. In terms of live solves, I really want to keep doing these TMUAs because those are the ones that are really challenging and that I have like more people for. So keep tuned on those. As always, you can pick up my process and the exam technique, so it might be useful even if you've already done the TMUA, or if you're not sort of directly sort of needing that for January. But with that, I've been with you for a while now. I think I'll leave you be. Keep working hard, guys. I will see you on Thursday for a nice little interview debrief. So tune in for that if you want to sort of, because that'll be good for, hopefully we get enough people that we can kind of discuss how it went and you can get a sense of how other people did. If you don't have a lot of people in your social circle who have gone for it, that could be useful. And so, yeah, I'm going to keep at it. I'll keep you guys posted whenever I go live. And in the meantime, work hard, have fun. I'll see you guys next time. All right, take care. Bye-bye.